Hello, can you hear my voice? Okay, so we'll start the class. Okay, in the previous class, we have discussed regarding the introduction of the metal forming, classification of the metal forming processes, okay, based on the nature of the force applied and also the on the base of the working temperature, okay. So the classification of working temperature, hot and cold working processes we have discussed in the last class. And some of the differences of the hot working and the cold working also discussed in the last class. Okay. So we'll next go for the forging. Okay. So the forging is a one of the important concepts in the metal forming processes. Okay, this is one of the important process nowadays also in the industries, mass productions, and for small types of job works. The forging method is very useful and essentially using in the manufacturing sectors. Okay, so the bearings, whatever the bearings, the car bearings, the door bearings, automobile bearings, where the bearings are being used for rotating of the shafts, maximum 90% of the bearings are being manufactured in a forging method. If you want to see the industry, when you comes to the Maratha Mandal Engineering College, when you pass the turn, your bus has been passing from the highway, you can see there is a Jinabakul forging is there, where there is a huge sound is coming. Have you experienced that sound? Have you heard that sound? Which sound is that? That is nothing but the hammer sound is there. Okay, at the left side, okay, at the left side of the Indologo, if you are having any opportunities to visit that forging industry, so you can see over there. Okay, so the Jinabakul industry is and one of the best example for the forging industry in Belgaum industrial area, where the escape bearings of the Pune, it is the main plant in the Pune where the escape bearings are being manufactured. Okay, the Jinabakul Forge is one of the best vendor, or the what you can say, the old vendor of that escape bearings, where they have manufactured escape bearings by the forging methods. Now, the forging is a type of a manufacturing process where the metal is heated to its plastic stage. In the previous class also I have explained the forging is the method in which the metal is being heated up to the plastic stage. Plastic stage means what? Below the melting point, the metal is heated in such a way that it should not melt. Only the property of the metal is being changed. The hard metal is converted into a soft metal. Okay, that is an below recrystallization. Okay, once the metal is heated and it's adopt the property of the plasticity, okay, the hard metal is converted into soft metal. That metal which is in a red hot condition, okay, once the metal is in a hot condition, the temperature of that particular metal is in a very high temperature. Okay, but the temperature restriction, there is a limit for the temperature to maintain, or the workpiece to be heated, that it should not access to its melting point. Once the temperature go beyond the melting points, what happens? That particular workpiece or the material which you are going to forge, that starts to melt over there. Okay, you should not melt that workpiece, you have to just only plasticize, soft that material. If the metal is in a hard condition, heat that metal in such a way that only it should be soft, okay, plastic form. Then when it's become a soft, impact of hammer blow or any of the load is been applied on that particular material. Okay, that material adopts the die shape. If there is at the bottom, if there is one die is there, on that die the particular hot material is been kept. Okay, metal is been kept on that metal, impact blow is been given. Okay, or a hammer blow is been given, by which it starts to change its particular shape. Okay, the above recrystallization temperature, okay, and below the recrystallization temperature. Okay, have you understood? Above the recrystallization temperature, below the melting point. Okay, so this is how the temperature is been maintained. If the compressive force is applied manually by using a specific tool is called as an hand forging. So compressive force has been applied. Compressive force means what? Both the side the force has been applied on that particular object. If that force is applied with any of the tool by manually means what? By your hand. That is called as an that tool is called as an hand hammer. So you are putting a nail into the wall. Okay, you are using an hammer to put the nail into the wall. Okay, that hammer is called as an hand hammer. If you are taking any of the machine, automatic machine, which is used for putting an impact blow on that nail so that the nail can insert it into the wall, so that machine is called as an hammer machine. Okay, so like this way there are different types of hand tools have been used in the forging. For the forging operation we will see discuss later the such kind of hand tools, which are the hand tools are being used and what are the uses of that hand tools. I hope you have understood what is the forging. Okay, just a blacksmith who is uh, working in your villages or anywhere you have seen the blacksmith. If you give a piece of a rod, of a metal rod, so he will heat that metal rod on a charcoal. Okay, then afterwards by with the help of the tongue is nothing but an holding instrument, is called as an tongue. Okay, so say in your home also, if you are picking up any of the vessel which is with an hot oil or the hot tea vessel. Okay, you are taking an tongue for holding that one. With a bare hand, you with your naked hand, you are not directly lifting that vessel because it is very hot. For that reason you are using any of the tool for holding that particular vessel to remove it from the gas burner and keeping aside. Okay, like this way there is a hand tool which is been used for lifting the workpiece from the hot furnaces towards the anvil, and for holding purpose also. That types of hand tools are called as in tongs. Okay, there are so many different types of tongs are being used. Okay, round tong, square tong, rectangular tong, it depends on the shape of the workpiece which you are going to be uh, forged. Okay, such to hold in that particular shape, the tongue is been given, the mouth of the tongue is been given by that particular shape. So the name is been identified according to that shape of the mouth of the tongue. Okay, so that particular that shape workpiece you can hold easily. Okay, if the workpiece is in rectangular workpiece, so you can use a rectangular tongue. If the workpiece is in square, you can use the square tongue. If the workpiece is in round, you can use a round tongue. Okay, for holding purpose. Now today, although the various machines and the equipments are in use for producing the quality of forged components, it is worth mentioning here that traditional forgings is performed by the blacksmith. Traditional forging means that from the ancient times the forging is been carried out. Okay, if you have seen in where there were the kings, warriors were there. Okay, there used to be the arrows were being prepared. How the arrows are being prepared? Okay, so the arrows were prepared by the blacksmiths only. Okay, so whatever the war instrument, war, what you can say, weapons, war weapons which are been prepared in the ancient times, they are made by the traditionally forging method only. The heat is being given to the bar, and by heating, the arrow shape is given to that particular bar. So that type of arrows are been used for killing the enemies and the animals also. Okay, so this is what from the traditional the forging method is the manufacturing method is coming out. And one more important thing is that the forging is been done for the complex shape. Okay, so the casting is also one of the important manufacturing method, but by the casting you cannot manufacture such a complex difficult shape components that can be easily manufactured by the forging methods. Okay, so this is one of the important manufacturing method. With a hand tool such as an hammer, anvil, so in the previous diagram I have shown you the hammer, anvil, tongs, chisel. Okay, see, I will show you in the diagram. There is no anvil, is there? Okay, we'll see in further. Okay. By seeing the diagram, you can understand the procedure, what is the procedure. Okay. The classification of the forging processes. The forging processes are classified by the degree to which the flow of material is concentrated during the processes. The three broad categories of forging processes. First one, open die forging. You can see over here. Open die forging, impression die forging, and closed die forging. Before going to that, you can see over here, read out one time so you can understand. Recrystallization. See, the recrystallization is a process by which the deformed grains are placed by a new set of undeformed grains, the nucleates and the growth until the original grain have been entirely consumed. The minimum temperature at which the completely recrystallization takes place is called as a recrystallization temperature. So see, what is this recrystallization? In the simple words I will try to explain you. So see, each and every metal material having its own microstructure. Okay, there are some small cells are there, micro cells are there. Okay, nucleus cells are there. Once you hit that workpiece or that material, what happens, that cells start to change their position. Okay, so they once they start to change their position, so that is called as a recrystallization movement. Okay, below above the recrystallization movements, once it starts to change the positions, okay, the property of that particular metal starts to change. Okay, the property of that material starts to change. For example, take a wall. Okay, in that wall, if you have taken a bricks, if you have constructed a bricks, okay, with the bricks or the stone you have constructed in wall, if you pick up any of the two bricks from that, what will happen, the tightness of that wall will be changed. Okay, the tightness of the wall will be changed. If any crack is given between the wall, the tightness of that wall will be changed. Okay, the load capacity taking of that wall will be changed. That means what, the property of that wall before full and fit with the bricks and the stone is different. Once you remove the any of the splitted stones or the bricks, then its property changes. Like this way in forging also, before heating, the property of that particular material which you are going to forge, that material property has been different. So once you heat that material, okay, then the microstructure changes occur inside the material. Once the microstructure changes starts to change inside the material, okay, so automatically the property of that particular material starts to change. Like this way, the material which is been heated, it goes to a plastic formation. Before it is on hard, then afterwards it go for the plastic formation. That means what, it is the material changing its property. A material is converted into a ductile or softness. Okay, so once the material changes property, so it is easy to forged. Okay, then you get a forged component. Then afterwards, once again that material starts to cool down. Okay, when it comes to its room temperature, then once again it changes its own property. Understood? So the three changes occur. Before, initially at a room temperature, no property change. Once you heat, the property change. At that moment only the compression force or an impact hammer blow is to be given. That particular material change its shape. Then afterwards, the material which is adopted the new shape, or there is a change of shape, it is allowed to cool. Once it cools, then it's once again starts to solidify and change its property. Okay, so this is how the forging operation is been carried out, okay, by changing the properties. Now let us see the classification different types of forging method. So you can see over here in this diagram, okay, they have shown the three diagram. One diagram shows the open die forging, second diagram shows lathe turning near the net shape, okay. Sorry, open die forging is there, and at the bottom you can see impression die forging is there. Then this is a closed die forging, okay. So like this way, three forging different diagrams they have shown, and let us see how the open die forging works and the lathe forging works. So see, over here you can see this is an square bar is there, okay. Initially it is a square bar is there, and it is been holded by the tongue or any of the, if the bar is in larger size, okay, any of the huge machine or the crane is being used for the gripping purpose of this bar or for the holding purpose, okay. Now you can see over here this is an anvil. Anvil is nothing but it is used for taking in support, okay, support for the workpiece when you give the impact blow of an hammer. Okay, so this hot workpiece, it is been heated in an external furnaces, and it is kept on this anvil, and this is an top die moving, okay, and this is a bottom die. So see over here there are two different dies are being used, okay. This dies also work like an anvil, okay. Now from over here it is fixed, the workpiece is kept, okay. Over here there is a die is kept, okay. You can see there is a die with anvil support, at the top there is a die with anvil supports. Now how does this forging works? Now you can see in this diagram, okay. So how this shape is changed? So see this is an initial shape, then afterwards due to the compression force this has been shape is changed. So see over here I will tell you, once the workpiece is kept, then this hammer which is in the weight up to approximate any weight, you can take 1 kg, 2 kg, 3 kg, or in tons 1000 kg weight, okay. This hammer giving an impact blow continuously as per the required cycle for 2 minutes, 3 minutes, 2 seconds, 3 seconds, 4 seconds, as per the requirement, okay. The continuous hammer is been blow is been given, okay. Now the compression force is generated from where, from which side? The compression force is always from both the sides, okay. From this side also force is generated, so it is fixed. So automatically from over here also the force is generated, because the workpiece is not shifting at a downward, okay. If one side force is there, so the workpiece will come downward. It is been stopped over here, that means what? Over here also the force is been adjusted to the workpiece. So once the workpiece comes under this impact blow, the size of that workpiece starts to reduce, okay, because it is in a hot condition, it the workpiece is in a softer way. Once the size and the shape is been given by the continuous blow of the hammer or the load applying, then the finishing is done on the lathe machine. The workpiece is been held between the two supports, and the tool is been used for removing the smaller cut from the upper cylindrical surface. So like this way the open die forging is been carried out for the forging operation. So this is the simple and working method which is nowadays overall the industries and the blacksmiths are been using for the forging purposes, okay. Now let us see the impression die forging. So what do you mean by the impression die forging? Before going to this, we will see some advantages of the open die forging and disadvantages of open die forges. Okay, so the advantage of open die forging is that a process is relatively simple, so it is very simple, no skilled worker is required. Only the what you can say, the power for the holding, the strength for the holding of the workpiece and giving the hammer blow, the strength is required over here. Okay, Then second one is an makes a use of a simple and inexpensive dies. So it is a simple, not an inexpensive dies have been required. Simple dies can be used in this method. The force component exhibit the good strength character. So force component exhibit the good strength character means what? The changing of the property is not much faster compared to the other methods of the forging. Okay, so the properties of that doesn't change in the faster rate. If the property changes in the faster rate, the strength of that workpiece may be weaker, or you can change will occurs. Okay, now next, what is the suitable for the larger size components that cannot be accumulated in a closed die. So the closed die is a nothing but a die which is a fixed area is there. You can see over here the closed die. It is a closed die diagram. So it is a fixed area. Within this area, okay, only that particular size workpiece should be fixed. Okay, so beyond the size of that workpiece, so die doesn't closed over there and you cannot get the accurate finished workpiece. For such type of workpieces you can use the open die processes. Okay, now let us see a few disadvantages of the open die processes. The process is limited to a simple shape. Okay, or limited to a simple shapes can be forced in this one. Okay, if the complicated shapes are there, complex shapes are there, so the better to prefer the impression die or the closed die processes. Okay, now next you can see the disadvantage. The skill operator is required for the proper manipulated of the workpiece during the forging. The skill operator is required, that means what? The operator which is moving the workpiece. So see, the operator who is moving the workpiece, he should have the knowledge with the how much blow, okay, in one stroke hammer. If you give the one stroke, so how much or how much centimeter, how much material that is going to be compressed, that knowledge he should know. According to that size of the compression, the movement of the workpiece in forward and the backward direction is to be done. Okay, for that movement, okay, the operator who is holding the workpiece or giving an hammer blow, or who is having the control on the movement of the workpiece, who is having the movement on the control of the workpiece as well as the hammer, he should have the skill knowledge that within one hammer blow this much material is been compressed over there. Okay, so this is one of the major disadvantage, okay, that should be identified, and this is what the remedy. Okay, he should have the thorough knowledge. Difficult to maintain the close tolerance. Difficult to maintain the close tolerance means what? The 1 or 2 plus or minus. If the workpiece is 1 or 2 plus or minus, that is what the tolerance. If just imagine, I have told you to make a 2 forged round bar from 20 to 30. 20 to 30 sorry, 30 to 20. 30 to 20 means what? The 30 is a raw material. You have to reduce that 30 diameter rod into a 20 diameter. Okay, and the length should be of 10 Okay, so the length is in 10 In that 1 2 tolerance is okay, is an ignorable, it can be managed. But in the closed die it is very difficult to maintain the tolerance. Only the, we can say, the rough work is been done. Okay, so it is one of the major disadvantage of the forging in the closed die. Now let us see the impression die forged. So what do you mean by the impression die forged? The impression die forging makes a use of a match dies. Okay, now you can see over here there are two dies are there. This is the first die and this one is the second die. Two dies are there which are having the same shape and size. Okay, same shape and size is there. Okay, first die and second die, shape same shape is there of both the die. Okay, when the two dies halls close, okay, the impressions from a cavity means what? The hollow part between, when the both the dies are closed, inside this hollow part is there, that is called as a cavity. whose shape is similar to that of the desired products. Okay, this cavity is just similar. So how the product you want, according to that this cavity has been generated. Okay, so see, this is what the final product which is coming out. Okay, so of that shape only the die has been prepared. The two dies holes do not fully close with each other. Instead, the design with a small gap between them. Okay, so see, there is a small gap is given, so they doesn't close together. This gap is preferred to a flash cutter, and its function has been explained under the heating notes. Okay, let us see. So see, in commercial application, the impression die forging involves the preforming processes like fluring, edging, blocking, etc. So it gives a rough shape to and desired products. So see, the simple thing is that, so see, this is a workpiece which is been heated. Okay, and this is an bottom die and this is an top die. So the bottom die is always fixed to the anvil. Over here there is, at the bottom there is an anvil is there. Okay, for that anvil the bottom die is fixed. Okay, and the workpiece is kept on this die. Okay, then this top die is there, it is connected to the hammer, or you can say any of the piston, okay, or the rod which is moving in a reciprocating direction from up and down direction. Okay, the movement can be controlled by hydraulical movement, pneumatically, hydraulically, pneumatically, or the any electrical movement is electrical motor can be used. Okay, by the belt pulleys can be used for the reciprocating movements. Okay, the hammer comes down, give the impact blow on this workpiece, then once again it goes up. Okay, then the workpiece size slightly reduced, then once again the hammer come down and give the blow on this workpiece, then once again the workpiece size is reduced, then once again the hammer comes down, then the workpiece size is compressed. Okay, so like this way the size of the workpiece starts to compress. Once it starts to compress, it covers whole gravity area of the die. Okay, so see, this is a workpiece. When it starts to compress, it covers whole gravity area, you can see in this part B diagram. Okay, and these gaps are being given between the two dies, just given for the flaring means what? Once the workpiece covered all the area, then the oil is been introduced into this hole. Either the engine oil or any oil is been introduced into this hole. Okay, so that the workpiece may cool down. Once the workpiece may cool down, it should not stick to the dies. Okay, then when the dies are been opened, the workpiece may easily removed out from that dies. So this is what a simple working procedure of a impression die forging. Now let us see the advantage of the impression die forging. First one, suitable for a small and medium size components and its large quantity. Okay, so impression die forging is used for only for the small and small size, that is a complex size components. Okay, in a large quantity you can produce, for the mass production you can do. The procedure, dimensional accurate forging, produce and dimensionally accurate forgings. So it can, the accuracy of this forging is very nice compared to the closed die and the impression die, because the workpiece is not, because the workpiece is not coming out of the die, it adopts the particular shape of that die. The workpiece material is not coming usually out of this die. Okay, and it adopts its particular shape, so there is no extension of the workpiece is there. Okay, so by which the tolerance of that workpiece can be maintained over there. Okay, now next we can see the disadvantage of the impression die. Not suitable for the larger size component, only the smaller size component and the material which can fit only within that die. Okay, such quantity material only can be used. Okay, beyond the size of that material, if the material is a larger size, what may happen, that the material may come out of that die. Okay, so how much material can be suited in the fitted in that die, that size material only are being used for the forging purpose. Okay, now next, initial die cost makes the process suitable for the mass production only. Initial die cost makes the process suitable for the mass production only. So see, if you are going to produce the thousands of products by this forging, okay, so what is the initial cost? Only that the initial cost is just, first of all, you have to prepare on a die. Okay, once the die is prepared, with the help of that single die, you can manufacture different types of not different types of, sorry, same design products. Okay, thousands of products you can manufacture. Okay, so this is what the disadvantage, that initial die cost is very costly. Okay, so the die cost is very costly, so that is, they have shown that it is a disadvantage. Okay, they are trying to tell. Now, next, what is closed die forging? So, what do you mean by the closed die forging? So, see, in this closed die, both the dies are been closed. You can see over here. The closed die forging is a precision forging in which the entire volume of the work material is closed within the die. No material is allowed to escape from the mold during the forging process. So, see, in this, so see the difference between the impression die and the forging die. Okay, so no excess material is coming out, but in the impressions the excess material is coming out from the gap, because the die is not closed over here. But in the closed die, what is happening? No excess material is coming out, total material is been total material is been inserted into the mold. Okay, as a result, no flash is formed. Okay, and for this reason the process is called as a flashless forging. Okay, what do you mean by the flash? You can see over here. See, I'll zoom it and you can see the flash. So see, this is the first workpiece is there in impression die. Once the workpiece has been compressed, okay, continuously, once the workpiece is compressed continuously, so what happens, the workpiece is been soft, what you can say, starts to extend and adopt the shape of this die, then the excess material starts to come out, the extra material starts to come out with the gap between the two dies. That material is called as an flash. So this is an flash, this is an flash. So in the closed die, the flashes are not coming out. Okay, so it is an flashless forging, so it is called as an flashless forging. So you can see over here, no flashes are there. Okay, all the material is been covered within this cavity. Okay, so it is called as a flashless forging. Okay, so this is what the difference between the closed die and the impression die forging. Now let us see the advantages. Advantages of the closed die forging. Okay, suitable for a small and the medium size component and in larger quantities. Okay, same is there, impression dies and this one. Close dimension to tolerance can be achieved. Okay, the accuracy is very perfect and the tolerance are also very good. Okay, no excess material is been wasted over here. Good surface finish can be obtained. Okay, so this is one of the important advantage of the closed die. So what are the disadvantage of the closed dies? Not suitable for the larger size components. Okay, because the die is been restricted and the gravity which is generated, okay, between both the dies is been restricted. Only limited, whatever the size of that cavity is there between both the dies, only that size workpiece can be hold inside the closed die. Okay, beyond the size of that cavity, the workpiece you cannot hold inside, because the workpiece, the both the dies shouldn't closed. Okay, you have to close that by applying the force. If the workpiece size is bigger, the die doesn't close over there, so automatically the flash is coming out, and the flash forging product is been coming out. Okay, that is a defect for that forging. Okay, so one more major disadvantage what they have given, the demand rigorous process control, particularly in the amount of starting the material to be used in the workpiece. For example, too little material result in the incomplete filling of the die cavity. Okay, if the material is in too little, it doesn't fill within the die quality. Okay, that is also one of the problem. And too much material will cause the dangerous buildup of the force, causes the die to jam or fail. So see over here, it is a very important thing that you have to understand. If the material is less, okay, if the workpiece material is less, so it doesn't fill in the cavity. If it doesn't fill in the cavity, what will happen? What will happen? If it doesn't fill in the cavity, you cannot get the particular shape or the size, this one, mm, product. If the material is excess, what will happen? The material will come out by the die. Simple example, if you're making an egg omelette, okay, so if you are having an pan, big pan is there, okay, if you put a single egg on that pan, so it doesn't cover whole pan, a small egg omelette will be prepared. If you put a 4 or 5 eggs on that pan, what will happen? The whatever the egg slurry is there, that will come out of that pan. Okay, so you should have the knowledge how much quantity of that material you have to put within that pan, so that pan can be full. Like this way, you, the skill should be very good, that how much size of that material should be kept, so that the particular die cavity can be filled properly. So this is a very important thing. Okay, in the closed die forging, so the operator who is using this cold die forging or the manufacturing process, if you are using this, you should have the knowledge of the sensing capacity, that how much material is been going to be used in this closed die forging. Okay, now let us see the forging. Now we'll go for the forging machines and the equipments. Now you can see the forging machines. So there are two types of machines are been there. So see, in the forging, only the hammer is very important thing. Hammer is very important. Okay, the hammer and press power hammer, that is an power press hammer. Okay, so gravity drop hammer is there, power drop hammer is there, pneumatic hammer is there, spring type hammer is there, and counter blow hammer. In press type, mechanical press, hydraulic press, and screw press. So these are the important forging equipments. Okay, then some of the hand tools are there, that also we will going to see. Okay, now this is a drop. Just mute your mic. All of you mute your mic, please. So this is, you can see over here, drop board drop hammer. Okay, so before going for the power hammer and gravity drop hammer, okay, so this is one of the gravity drop hammer it is. So I will show you in the diagram, so you can understand what is the forging method and what is the hammer uses. Now you can see over here, there is an anvil is kept. Okay, on this anvil there is one die is there. Okay, this is what the die is there on the anvil, and over here the round shape, square shape workpiece is kept. You can see the workpiece which is in a hot workpiece, it is in a heated in the furnace.